Alright, building a multiplayer chess platform. Let me set the context for the video. This video is going to be divided into 5 parts. Part 1, a very basic system design / architecture of a chess playing platform. Part 2, we'll be writing the backend for it in Node.js in less than 150 lines of code. Part 3, we'll be writing the front end for it, very simple components, a very basic landing page, and a simple chess playing arena. Step 4, we'll be understanding how can we make this a little more resilient and fault tolerant. Step 5, we'll understand how do you scale an application like this. The code that's written right now is a very basic chess application, one that you would build in a hackathon in your college. It's very easy to follow along and code it, but there are some inconsistencies in it. I've put this code on GitHub and filed an issue for the next steps. If you want to ensure you're not stuck in tutorial hell, if you want to follow along but do something extra on top, I would urge you to look at the issue after you're done with the video and try to solve it yourself. That's the best way to learn if you've ejected out of tutorial hell. With that context, let's get right into the video. Alright, hi everyone. Let's build a chess.com like platform. The goal of the video is to build the core of this system. What do I mean by the core of the system? I mean the main logic that connects you to people all around the world and lets you play a multiplayer chess game with them. Our final website will be a smaller subset of what you're seeing here, but eventually the goal is to add more things, authentication, a place for you to track your ratings, so on and so forth. The goal of this video is to understand the system design of building something like this. I think I have 2-3 ideas, each with their own pros and cons. So we'll try to understand which one is better, which one is probably good for us to choose right now, which one we can choose later on as the application scales. And number 2, the goal of the video is to actually build this and hopefully deploy it. So if you're watching this on YouTube, I hope there is a live link somewhere in the description where you can go see a button like this, which says play online, click on it. And once you do, you will get connected to someone all around the world. Hopefully someone else is active on the website at that point. If they're not, then of course you won't get connected. You'll be stuck in waiting. And then you can play chess against them. Very similar to what's happening over here. The tough parts of building a system like this include, number 1, you need to have chess validation logic everywhere. I can't, just take this and put it anywhere random. I need to put it on certain points. Number 2, this is multiplayer. There are multiple people all around the world. So there needs to be some central game logic. Number 3, maintaining all of these moves somewhere in a database because there is no authentication right now. There's no identity attached to every move. It's just a random user and a list of moves that they played in a specific game. Number 4, I think the front end for this is a little challenging because, you need drags and drops, which aren't hard necessarily, but you have to make a choice between using something like React or using, some sort of a canvas over here. Number 5, how to scale something like this. This is a plain game between 2 people, but as, maybe 100 people subscribe to this room in view only mode, which is, pretty possible. You want to allow other people to be able to watch a game. Then this becomes slightly challenging because how do you scale to 100 viewers, to 1,000 viewers, to 10,000 viewers? So we'll talk a little bit about that as well. That's a brief of what we're building. What are we not building? We're not building the core authentication. We're not building puzzles, learn any of that. It would be good to add authentication. I think that will be next step. But if the core of the system is built, all the auxiliary services are slightly easier to build around it. We're going to focus on the crux of a real-time game. If you build this, it's very easy to build a multiplayer Ludo game, a multiplayer snake game, basically any multiplayer game where there is a game board, everyone can take a turn, play something, and then that gets synced with everyone currently in the game. As long as there are, less than 10 people, the architecture that we will decide will work for a chess game, for a Ludo game, for a snake game. If there are more than 100 people, more than 1,000 people, then this becomes slightly challenging. But thankfully, most board games aren't that. It's usually, 2 to 5 people. With that context, let's get right into the video. Let me take you to the system design of building a chess.com like website. Right. As 2 people reach your chess playing platform, let's say this is browser number 1 and this is browser number 2. How do you think they should talk to your backend? What do you think the backend protocol should be? Do you think it should be an HTTP server? Or do you think it should be something else? Notice this is a real-time game. There are a lot of events that need to happen and exchange between both the browsers. If these are 2 browsers, if I make a move here, this move needs to reach browser 1. If browser 1 makes a move here, this move needs to reach me. This basically means there are a lot of events that are being exchanged between the clients and the server. And a lot of times the server needs to push events to the clients. The client doesn't necessarily need to ask for them. For that reason, it makes a lot of sense to not use an HTTP server, but use a server that lets you create a more persistent connection. WebSockets are one of many protocols that let you do it, and is the one that we'll be choosing, is the one that I've seen most real-time games use. So when you reach this specific page on the chess website, you should create a persistent connection to the backend server. And this is how you will exchange messages with the server. This is how the server will let you know if there is any event that you need to be subscribed to. What are these events that you will push? Well, anytime you go to the board and make a move, this event needs to be pushed to the WebSocket server. What are the events that you will receive? Anytime your opponent makes a move, this move needs to be transferred to you, and WebSockets are the easiest and probably the most popular way to do this in a real-time game. All right, next up, let's understand, given these connections are already made, we have a persistent connection between browser 1, browser 2, and maybe a bunch of other browsers. What events need to share between the browser and the server? The very first event that any browser will publish to a server would be when the user clicks on the play button. When the user has clicked on the play button, the browser is letting the server know, hey, I want to initialize a game. Please connect me to either a pending participant that might be waiting, or make me the pending participant. I am ready to start my chess game. Whenever this event goes from this browser to the server needs to maintain that this browser 1 is currently waiting for an opponent. It can store this value in a variable or push it to a queue, does not matter either way, that this is one pending participant that's waiting for an opponent. Whenever the same init game event comes from another browser, it will know, okay, browser 1 was waiting, and hence I need to start a game between the socket from browser 1 and the socket from browser 2. A game will be started for both of these users. And whenever a third user comes and joins your platform, they can also, the logic remains the same. The cycle continues. Whenever browser 3 sends the init game event, browser 3 is what's stored in a variable here. And whenever browser 4 comes, browser 3 and browser 4 get connected into the next game, so on and so forth. A good question to ask at this point is, Kirat, why are you not maintaining a queue? It feels like, people are waiting in a queue and then someone else is coming. Why not push them to a queue? Why are you maintaining a single variable? And the answer is there is no need of a queue. At any point, there will at max be one person who's waiting in a queue or like currently waiting to be connected to someone else. So a single variable called, waiting to be connected is good enough. You don't need to maintain a complete queue where you keep pushing people. A single variable is good enough. As browser 1 and browser 2 get connected, there are a few other things that happen. There are a few other events that browser 1 can now push and browser 2 can now push. Let's understand what happens then. All right, when the server knows that there is a game currently ongoing between browser 1 and browser 2, the server can maintain the current state of this game in an in-memory variable. So if this is the backend server, it can have probably a variable called games, which is an array of type probably a game class. And this game class will look something like this. It will have the opponents that you have. So participant 1, participant 2, but most importantly, it will have the current state of the game, which means probably what the board looks like right now for both the people, and all the events that have happened, all the moves that have been played by either of the participants. Maybe another thing to store over here is the start time. When was the game started? And I think that's all that you need for a chess game. Given the start time and the moves that have happened along with their timestamp. So, E4 happened at timestamp T1. That's probably the first value here. And then E5 happened at time T2, so on and so forth, is good enough to store the state of the current game. is also good enough to recreate the game. Given this, there was a participant 1 and participant 2. This is the current state of the board. And these are the moves that were played since the beginning. And this is the start time. This is enough information for you to recreate the board at any point. And what do I mean when I say recreate the board? I mean to be able to see all the moves over here in the UI, to be able to show the user the current board as it looks like. So this much information is good enough to store. Harkirat, is it a good idea to store it in memory? That is a question we will be getting to eventually, but this is the most scrappiest design to begin with, where you're storing the current state of the game in a in-memory variable. As your server has more than 2 games, let's say there are 100 games going on, then all of these are in-memory variables of the type game or the class game that you're storing on the server. Anytime I make a move, anytime I let's say do this, I send an event to the server, let's say E4 or E3, and then the server needs to find the game that's currently active for this user and store this in the move. The server also needs to recalculate the current state of the board, and that's good enough. That's all that the server needs to do. Eventually, when the clock runs out, how does the checkmate happen is something we can get to. But for the initial bits, the server just needs to, number 1, validate, can this user make this move? Number 2, store it in the in-memory game object. Once the first user makes a move, the second user will do the same. Then that also gets stored in this in-memory variable. As time goes by, this game object will become very long and very complex. And at some point there will be a checkmate and you can call it quits. Let both the clients know that there was a checkmate by sending an event, from the server to either of the clients. But for now, what is the system design? It's pretty simple. Whenever 2 people join and whenever a game starts, like we have a game over here right now, both the parties will send a move one by one. If the first party, let's say, sends an E3 move, the move gets stored in this variable. The move also gets broadcasted to browser number 2. And then the browser number 2 can send a move that also gets stored in a variable and gets broadcasted back to browser number 1. Of course, whenever there is a move that reaches the server, number 1, you need to do validations. You need to make sure, can the user actually make this move on this chessboard? Number 2, you need to check if there is a check or a checkmate and, broadcast that information along to either of the clients. Is this a good system design? It's decent. It's not great. Harkirat, why is this not great? Seems pretty foolproof to me. This isn't great because if your server ever dies, which is very possible in the real world, your server can crash from time to time, then you lose all of this information. You lose everything that you had stored in memory and you cannot recreate the game. How bad would it be if I'm playing a game and in the middle of the game, the server crashes and I cannot recover the state of the game? All that information is lost. And hence, even though this approach is great for a beginner, this approach is great to code out initially, you should always assume that your servers can crash. And when your server crashes, you need to bring it up immediately and recreate the state of that game, which is something you cannot do in the current system design. Harkirat, how can you add recreation of games to this? We'll get to that eventually. Let's try to code a basic in-memory chess-like game where people can sort of talk to each other and the game sort of continues. This in itself is mildly complicated to build because you need to add chess validation logic to the front end, to the back end. You need to build the front end for the chessboard. So this itself will take up a decent chunk of our time. But the good thing is, once this is built, it's very easy to build on top of this. And what do we need to build on top of this? Number 1, recovery mechanism. Okay, if the server dies, how do you bring it back up and recover the state? Number 2, scaling mechanism. Right now, we're just assuming that there is a single server over here and your clients are going to send events to the single server. If you have multiple browsers and 1,000 people connected, all of them are connected to the same server. That is not the best approach. You want to be able to auto scale. If you have 1,000 users, 10,000 users, you need more servers to come up. We'll understand in the third section of this video, how can you auto scale. But before that, let's build this and see, how hard is this to build. The reason I want to build the scrappy version is it's number 1, more implementation based. I like to code. And number 2, we will have a base checkpoint for the second part of this game where we add some recovery logic to chess. That system design is fairly interesting in case you're thinking of sticking by until that point. So the next section is going to be me coding a lot, and we'll try to build a basic version of this game. Quick call out, if you don't want to get into the code, just skip through the next section and go to the real system design. Don't share this system design with anyone or in an interview. This is not the cleanest system design. There are a bunch of problems in it, which I will discuss after I code. So if you don't want to code, feel free to skip this next section and then dive directly into the problems in this approach and then approach number 2. All right, I have a fairly empty project right now. I'm in a folder called chess, which if you look at it, exists in /users/Hakirath/projects. It's an empty folder right now. I'll be adding a bunch of folders here. Specifically, the ones that we'll be doing in this module are, I call it backend 1 and the front end. The reason I'm calling it backend 1 is because we will improve upon the backend eventually as we reach section 2, section 3 and get into better system designs. Frontend will remain the same. The API for the frontend to talk to the backend will remain the same. Nothing much will change on the frontend. Just what service it is talking to, backend 1, backend 2, or a different one, would change as we progress through the video. Frontend is going to be a simple React project. Backend is going to be a simple Node.js process. Let's start by initializing the backend and let's code the backend first. That's usually the better strategy. Eventually we'll get into the frontend and, code the frontend bits. I'm going to initialize a package.json here. npm init-y to do that. I'm going to initialize an empty tsconfig.json because this is going to be in TypeScript. If you don't know TypeScript, feel free to skip the TypeScript bits. There won't be like a lot of them. Now let me change the tsconfig a bit. Let me change the out directory to /dist. So all the final JavaScript compiled code goes to the dist folder. And let me change the root dir to /source so that all my source code gets picked up from the src directory that's over here. In the source directory now, I'm going to introduce the index.ts file where I'll be writing most of my code. If you remember the system design, what were we building? It was a WebSocket server that we were building. Specifically, this is the logic that I'm writing right now. And eventually we'll be writing the front-end logic as well. What does this need to have? At the very least, it needs to have a WebSocket server. There are many libraries that let you create WebSockets in Node.js. The one that we might use today is probably going to be the WS library. It'll pretty much bootstrap a WebSocket server for us, so we don't have to, write all the logic to create a WebSocket server. No one does that. You just use an external library similar to the one that I'm showing you on the screen right now. That looks pretty simple. Oh, that's the client. Let me install the WS library, npm iws. Feel free to use yarn, bun, whatever is your favorite package manager. I shall see a bunch of red squigglies here. Probably need to do a npm install at types/ws. That will bring in the types for the WS library and we're good to go. This much code should initialize a simple WebSocket server. Hakirath, that's all you had to write? Yeah, I think the first backend will be less than 100 lines of code because this isn't too difficult to build until you reach, some complex system design. How can we test that this works? It says const WebSocket server equal to new WebSocket server on port 8080. And anytime there is a connection, if there is an error on that specific socket, you should log that error. If there is no error, if there is a message that comes on that socket, you log it. And we are also sending a dummy message to the end user. We don't need this, but feel free to look at it from top to bottom. Feel free to take a pause here. This is the first bootstrap of our application. Irrespective of if you're building a Ludo game or any real-time game, you will see this logic everywhere. I don't think this is enough. I think we need to bring in an HTTP server here. But let's see. Let's do a tsc-p to compile this code. And then let's do a node dist/index.js to start it. Seems like it is running something because the process did not exit, but I could be wrong. We might need a server as well, an HTTP server. How can we test if this WebSocket server is working or not? I think that this thing is working. Of course, there is no game logic. How can we test if this is working? We can try to connect to it in a dummy fashion. How can you connect to a WebSocket server from not your browser, but using a dummy client? The answer is using Postwoman or what's called Hopscotch now. So if I go to Hopscotch, click on real time and select ws://localhost:8080, which is what I see here by default. If I connect, seems like it worked. Seems like this much code that I've written over here is actually good enough for you to create a WebSocket server. How do I know this? Because I said in this specific website, okay, let me connect to this WebSocket server. And when I connected, as you can see, it says connected to ws://localhost:8080. It also got back the something message that I sent. Eventually, we'll be sending messages like E4, E5, which is a move that happened. And eventually, the client will also be sending a few messages that look like this, E3, E4. If you send this message, it's getting received on the server. So we have established communication between a browser and a server. Of course, this browser front end is very different. This isn't a chess website right now, but we can easily replace this with a chess website as long as we have proved that the WebSocket server is up. And as you saw, it's like less than 14 lines of code to do that. The logic remains pretty similar, irrespective of if you build this in Golang or Rust. You have to create a WebSocket server, and then you have to handle a bunch of messages from the client, forward a bunch of messages to the clients. Given we have this much logic, what do you think is the next step? What do you think should happen as the front end sends you a message like init, it's hard for you to see it, init_game. When the front end sends you a message that looks something like this, what was the logic that we thought of? We said, whenever we receive an init game event, we store it in a variable on the server called pending users, or someone who's currently pending. So we can create a global variable here, or we can clean things up a bit and create classes. Depends on how you want to write your code. Ideally, you should create classes. I think that will be the cleaner approach. Else this file will fill with a bunch of logic. So let's create a new class here called game manager. Let's create game manager.ts, which will be a global class that will handle a bunch of your logic, including, creating the current set of games, managing the current set of games, so on and so forth. So let's create a variable called games over here, which is of type game array, where the type of game is can be players. It can also be player 1 WebSocket, player 2 WebSocket. ID should probably be a class, if I'm being honest. I'll get to what this game.ts class is. For now, let's just have a constructor which initializes this games array. And then have a function called add user with their socket. Remove user with their socket. And handle message which can be a private function, does not need to be called from outside. Ignore this reds quickly for now. Ignore what game would be. Let's go back to index.ts, and anytime a user connects, anytime there is a user connection, we should do first we should create a global variable called game manager equal to new game manager. We should do a game manager.add user with this specific socket. Socket. There we go. Game manager dot add user, and that is it. Nothing else should be done here. Well, one more thing maybe. WS dot on disconnect, is it? Message error. There we go. WS dot on disconnect. Call game manager dot remove user. If this is an event, I think it is. Could be wrong. We will eventually check it. So the game manager is basically a class that we're creating that is going to manage all of your games, and we're trying to keep the index.ts file as clean as possible, so that it does not become a very big mess to look at eventually. Another variable this needs to have is private pending user, which is going to be of type ideally WebSocket, but you should have another class called a user class. We need a user class. We need a game class, because users can be more and more complex. I guess WebSocket is fine for now. And anytime there is an add user, we should check. Actually, we shouldn't check anything. We simply need to probably just maintain a list of users. This dot users dot push socket, remove user, this dot users dot equal to filter it, and stop the game here because the user left. This is also not great. You should have reconnect logic, but we'll get to that later on. We have a game manager class which has a list of the games. It has the pending user, which is a user who's currently waiting to be connected, and then a list of currently active users on the server. Lastly comes handle message. Anytime a user comes, you should attach a bunch of handlers to the messages that they're sending. For example, socket.on message data. I'm going to call out something here. You should probably use gRPC for this. I'm not going to, but it's probably a cleaner way to do this. Righty. Yeah, it's helping us out here. If message.type equal to join underscore game, or what was it? Init underscore game. Should probably be another class here called messages.ts, which has export const init underscore game equal to init underscore game. If the type of the message is init game, what do you think should happen? When the client sends you an init game message, you need to check if this dot pending user exists, means you start a game. Else what do? Else you simply set this dot pending user equal to the socket. Okay, this is a user waiting to be connected to someone else. But if that's not the case, then you simply start a game. The question is, what happens when you start a game? And if you remember, I told you a while back, we'll probably have a game class that he will initialize when we have found the two participants. When you've found the two participants, probably want to create a new game, an object to a game class, which has all your participants and the initial state of the board, which will, of course, be an empty board, moves, start time, so on and so forth. So let's do that. Let's create a game class. I already created game.ts. Let's try to export a class from here. Export class game. Constructor will take player one, which is going to be of type WebSocket, which again, I think that there should be a class that we should create called the user class, but WebSocket is fine for now. We need to import this from the WS library. Private player one WebSocket. Private board. The thing about a chessboard is you can actually represent it in the form of a string. You can also do this string array, like a two-dimensional array, but you don't necessarily need this. You can describe a chess game in the form of a string, which initially is going to be, I'll share very soon, but something like pawn. You get the idea, queen, so on and so forth. I'll come to what this notation is and how you can store it. What are the other things you need? You need moves and start time. So private moves, these can probably be an array of string, e4, e5, e7, e3, so on and so forth. Needs to be initialized to an empty array. And lastly, start time. This dot start time equal to new date. Whenever a new game is created, an object should be created for this specific class. So let's do that. Let's go back to the game manager and if there is a pending user, what will you do? You will const game equal to new game. Export class game. This dot pending user, comma socket, comma, that's good enough, I guess. Game needs to be imported from ./game. And then we probably want to push it here. If you remember, what did I say? We'll maintain a global array of all the games. So let's do that. This dot games dot push game. And then lastly, this dot pending user equal to null now, because the pending user, whoever is the next person that comes, is now going to be the pending user. This dot user is equal to empty array. All right. If the message type is init game, then you do this. You can clean this up and you put it in a different function. Probably should do that. If message dot type equal to move, which means a user is trying to make a move, e4, e5, something like that. What do you need to do? You need to again forward it to the game manager. As I said, the game, sorry, not the game manager, forward to the game. The game is what is going to handle, all the moves getting added, the state getting updated, so on and so forth. So if the user sends you a message, you simply find the game. There you go. AI helping us out here. This is .games.find either game.player1 equal to socket or game.player2 equal to socket. That sounds right. You can make this slightly better if I'm being honest. But it's fine for now. Let's make the game class variables public. Yeah, there can be an easier way to find the current game or, the game of interest here, but this logic is fine for now. And if the game exists, do a game.makeMove with the socket. Okay, this specific user is trying to make this specific move. We also need to initialize a makeMove function in game.ts now, which will take the socket as well as the move as an input. Again, I'm keeping move as string because, you can make it more complicated. You can be like, I don't know, start position, which is an array with 2 values, or, a tuple, and then end position. But a string works. Every move can be represented as like a bunch of characters, e4, e5. So let's just use that. And this looks pretty good. If this dot socket equal to player 1 or the socket equal to player 2, that looks wrong. You need to do number 1 validation here. You need to make sure, is it this user's move? Number 1. What is the other thing you need to make sure? Is the move valid? Number 3. If that is the case, then you need to update the board, push the move, and then you need to check if the game is over. That is correct. And then lastly, send the updated board to both the players. A single player is also fine, but let's just assume we send it to both the players. How do you do validation, Harkirat? How do you make sure that the current move that's coming in is correct? How do you create the new board, Harkirat? You to stored board as a string. How can you, what was the string format that you were talking about, and how will you update this string format to something else? Pretty good question. And the answer is, there's like standard notations in chess that, if I'm being honest, even I'm not too aware of, but there's a library called chess.chess that I looked at a few hours ago when I was researching for this. That pretty much lets you, that'll pretty much handle a bunch of validations for us. Harkirat, why are you not doing this in-house? Because, well, there's a library that does it, and you can do it in-house. If I'm being honest, I might have a chess validator on my GitHub because I built this back in college. Let's see if I do. Quick detour here. Let's search for chess. king.chess. There you go. Oh, never pushed anything to it. Would have hoped I did. But I think I built this back in college. A library called king.chess. Did not push it. But this was like building a multiplayer chess game was actually my first year project. Which sort of got me interested into chess a little bit. And then I created this awesome chess library. But yeah, we're just going to use a validator. We're not going to build it in-house. Chess.js is a decent, I mean, I don't know, there might be a better one. This is the first one I Googled and found. And it does pretty much everything. If you look at the code, you can initialize a new chessboard, and then, initially the moves would be empty, and then you can make more moves. For example, the initial board will look something like this. Bunch of pawns, and then, whatever the notations are over here, and then empty board for a while, and then a bunch of pawns, and then, black. And then whenever you want to make a move, you can just do a e4, e5, f4, or whatever your move is. And then at any point you can print the board if need be. You don't need this. You can print the FEN notation of it, which pretty much means printing the board in this string format. I hope. And what else can you do? You can .get square. You can check if there is a check, and you can check if there is a draw. You can also check if there is a stalemate. You can check if there is a checkmate as well somewhere here. Pretty sure you can do that. Is game over, I guess. Oh no, there's something else. Is checkmate. There you go. So basically this library, as long as you're giving it all the moves that have happened, will give you variables like is checkmate, is draw, that you can use to, let the front end know if the game has ended or not. From what I checked, this library has a not too strict but not too not strict license, which basically means as long as we have their copyright notice in wherever we're distributing this code, should be fine. We will have to use this library both on the front end and on the back end, but we will see why on the front end, why on the back end very soon. To kick things off, let's initialize this library into our code base. Right, that's done. Let's, rather than maintaining a board and moves, we can now maintain a variable called board, which is of type chess, where chess comes from chess.js. So basically this variable board is of type chess, and anytime a game is created, we create a new instance of the chess class. Expected 2 arguments but got 0. What arguments do you expect? Now I hope this is in TypeScript. Seems like it might not be. Constructor fen, which is an empty string. What is it saying? Game.ts an argument of player 1 was not provided. Oh fuck. New chess actually. Yeah, my bad. Yeah, sorry, it's 4 a.m. So initialize a new chess variable and start time. It's not being used, which is fine. Cool. Given that you have this board, now anytime the person makes a move, what did you have to do? Validation. So you have to check, is this a valid move? So if there is valid move, valid. Dot move standard notation, dot move object notation from G2 to G3. It's probably is a better way. Yeah, probably want to use this. Question remains. Yeah, it seems like this will do all the validations for us. If black is trying to move, it won't let it. We can also add those validations ourselves. Either way, let's do this. Let's change the type of move that the user is sending us to be, the type of this move basically is any right now. We need stricter types, but I don't want to complicate the code here. Let's assume that the type of move is something like this, from, which is going to be a string, and then 2, which is going to be a string. That sounds right. Basically means, something like this. And this is the function that we will call. So we can pretty much do this dot board dot move from basically pass in the move variable that we get. Should add some validations here. Validate the type of move using Zod. All right. And we should put this inside a try catch. Thankfully, this library will take care of throwing an error if this is an invalid move. So I don't have to do it. I can add some more logic in here to make sure, for example, if this dot board dot moves dot length is odd. Yeah, basically what AI gave me here is even, and socket is not player 1, which means player 2 is trying to make a move. When it's player 1's turn, you return, and then do the same thing for the other side. So you can add this logic. Probably don't need it because this board move will check it. So here is where there's an error, which means this was an invalid move. But if not, you make the move. This board chess.move, board.move. What does it return? Returns a bunch of things. Chess.move returns these things. Doesn't matter. Yeah, that's all you need. Update the board. We don't need to do that because thankfully the library is handling all of it for us. The chess.js library. Check if the game is over. That's a good thing. If this dot board dot is game over, then send this to both the parties, basically to a player 1 dot emit a message that looks something like this. Type game underscore over. Let's go back to messages.ts. And you need to stringify it because you can only pass strings via a WebSocket server, or via all WebSockets. If game is over, then send them this and let them know why is it over. Payload winner is this dot board dot turn. Yeah, that looks right. This dot board dot turn equal W, then black else white. Turn is a function. There we go. Colors dot and W is fine, I guess. Cool. Looks pretty decent, but if the game is not over, then you need to tell the other side that the move has been made. So this dot if, yeah, there you go, else, thank you AI, this dot player 1 dot emit. The only thing is this should probably be move. There we go. That looks pretty decent. I think that's all you need for the backend. Yeah. Let's look at it one more time. What does the make move function do? Whenever this function gets called, which it will get called when there is a message on the socket of type move, which means whenever the user is sending a message to this WebSocket server that says, hey, I want to make a move, the control would reach here. It would check the type of the data, and the type of the data would be move, that the user wants to make a move. Then we'll find the relevant game for that user and then call game.makeMove. What would game.makeMove do? It would actually update the board and make that specific move on the board, and then check, is the game over? If it is over, it will let probably both the sides know, not just one, that the game is over. But if it is not over, then it will let the other party know, based on who is the party who currently sent the message, that hey, the other person has made a move, it's your turn now. What's missing here is time logic. You need to end the game if the clock runs out, things like these. We'll add that in a V2. I think this is a good V1. If this is done, let's see how the front end needs to be built before that. Let's try to see if it actually works. Let's Yeah, there's one more thing we should add, which is whenever the game starts, which means, the constructor comes here, we should let the parties know that the game has started. So, there you go. Let the player 1 know, let the player 2 know that the game has initialized, and their colors. So you're white, you're black, or multicolored. I mean, we love everyone. Cool. Given that that's the case, let's see if it works. If you don't understand the code, but it's less than 77 lines of code here, 4 lines of code here, 50 lines of code here, and 11 lines of code. If I add that up, it's probably 130, 120 lines. I don't think number of lines of code is ever a metric. So I'm not saying this is easy by any means, but this is standard. If you understand this, then, creating any other real-time game, be it, something like gather.town, which is, a $1 billion company in itself, creating a virtual space where people can move around is fairly similar. You have events in real time that are being transmitted. If you want to create Ludo, if you want to create any other real-time game, the logic remains fairly similar. Let's try to test this code without writing the front-end code. Let's see if it works with, a simulated client, and then we will actually write the front-end code for this. I haven't tested anything, so there might be a bug here. Let's figure that out, live coding. All right, cool. All right, let's see if our code works or not. Again, to quickly revise, what have we done? We've effectively just created a simple index.ts file, which initializes a game manager. And anytime a user connects, we do a game manager.addUser. Anytime a user disconnects, we do a game manager.removeUser. We have not added any implementation here. Inside addUser, we push this to a list of users. Again, we don't really need this. We call .add handler, which attaches 2 message handlers to this socket. If the user is letting the backend know, okay, hey, I want to initialize a game, then we check, is there already a user who's waiting? And if they are waiting, we start a new game. If there is no user waiting, then we create this user as the pending user so that whenever the next person joins, they're able to, a new game is created between these 2 parties. If message.type is move, if a game has already started and people are moving their puzzles, then we find the relevant game and then call game.makeMove, and most of the logic to actually make the move on the server and update the board on the server happens in this make move function, which first checks, is the move right? Is the person that's trying to move, is it their turn or not? And if it's not the case, we early return. Then we do a this.board.move. Should probably add a log here in case there is an error. And then we check, is the game over? If the game is over, then we let both the parties know that the game is over. If not, then we, make that relevant, let the other party know that this specific move was made. So it's your turn now. Cool. That's a brief of what we've written. Let's try to compile this code and then run it. And let's see, does this work if 2 parties are trying to talk to each other? Let's open Google Chrome and then open Hopscotch again in 2 tabs. And let's try to connect to the server in both of these tabs. Now we have 2 browsers that are connected. Basically have, a setup that looks like this. Browser 1 is connected and browser 2 is connected. None of them have emitted the init game event. So let's do that next. Let's emit an event over here called init game. Let's look at what the body needs to look like. Message.type equal to init game, which looks like this. So basically something like this. Type init game. The first party sends that message. Nothing happens because the first party becomes the pending user on the server. They become this thing right here. And what happens when the other party does the same thing? Then the game actually starts. So let's go to the other party and send the same message from here. And now, as you can see, along with my message going out, I receive a message from the server that says you are black. So the second browser is going to be black, and the first browser receives a message that says you are going to be white, which means that at least game has initialized on the server correctly. If 2 parties join, if 2 parties want to initialize a game, both of them get connected and both of them receive a message that the game has started. You are white and you are black. Next up, why it needs to make a move. Let's see if I send a message that looks like type move, message.move, type move, and move is going to be from, oh god, chessboard game images. Is it going to be A2 to A3 or is it going to be H7 to H3? Probably going to be A2 to A3, I would assume. So the move is going to be, or at least we're going to go with this, A2 to A3, which basically means, take the pawn up a level. And let's see if this move works. If this move works, then, this event should get transmitted to the other side and the other side should know it's that done. Let's see if it works. Send. The payload was sent and the other party did not receive anything, which means we have a bug that we need to fix. And we also have a lot of mosquitoes in this room. Let's see what the bug is. Let's start here. Does the control ever reach here? Console.log inside move. And then let's see if the control ever reaches here inside make move. And then let's see if the control reaches. Oh, actually, was there an error? Let's see. No, there was no error. Let's see if the control reaches here. Did not early return. And then lastly, see if the control reaches here. Move succeeded. And then that's if it reaches here, then probably, the image should happen. So let's see what's up. Let's recompile the code with a bunch of logs and connect, initialize, send, initialize, send, and then let's send the move. Let's look at the server. Did not early return, move succeeded. The control reached here. The control reached here. Why did player 2 not receive? If this .board.moves.length %2 is equal to 0, then this, okay, let's do a log here. Harkira, should you do log debugging? Not really, but it's fine. We can put like breakpoints here. That's probably the easier way to, or the better way to debug, but this is fine as well. Send to, let's recompile with some more logs. Let's redo everything we did. So connect, send the init message, and now this side is white. Send the E4, A2, A3 message, and it says 0 sent, which means, this did happen. This .player2.emit, is emit the right thing or is it sent? It is sent. There is no such thing as emit. That's probably what's wrong. Let's try that one more time. Compile the code, run it, and connect. Let's send the init message. Let's send the init message, and then let's send the A2, A3 message, and it gets received on the other side. And now let's make a move from here. Let's do E2 to E3, send, and it did not reach here, probably because inside make move. Yeah, it probably already returned. Why did it already return? When I did a E2 to E3, this is black, this is black. I did a E2 to E3, send from E2 to E3. If this .board.moves.length, let's log this .board.moves.length. Early return 1, early return 2, recompile, connect, send, wrong one, init game, let's restart, connect, send init game, send the move A2 to A3, it reached the other side. As you can see here, send the move E2 to E3, and it does not reach the other side because early return 1 gets called, which is this thing right here. If this dot moves dot length, why is it 0? It should be 1. One move has been made. Oh, moves is a function. Not bad. All right, let's try that one more time. Moves dot. All right. tsc-b node/index.js. Let's do a connect. Let's do an init game. Let's do an init game. Let's do a A2 to A3 for white. Reach the other side. Let's do a E2 to E3 for black. I sent the message and it still did not get received here because early return. Why though? If this .board.moves.length, this .board.moves, I guess moves has E2 as one value, E3 as the other value. That's my guess, but we'll see. Send A2 A3 for white, E2 E3 for black. Did not reach the other side because, oh boy, yeah, this is what moves looks like, which is weird. Yep, that's not the right thing to look at. This dot moves, remove is header is game over. Let's print the board and see if it's actually right or not. All right. Either we're making too many moves or, the moves array is not right. Either way, should be an easy debug. Send A2 A3 received on the side, E2 E3 send. Okay. Oh boy, board looks pretty complicated. Square type R. Right, bunch of pawns. This is black. Let's look at white. Bunch of pawns, but the first one is null. So that looks right. Yeah, so the moves are happening and they're happening the right way. Just moves is not the right array to look at. How do you know the number of moves that have happened? Okay, moves takes a bunch of inputs. Move, whatever is move. Oh, this is wrong. We don't want that. What is this? Which one of them returns move array? I guess we can just maintain the move count, even though I don't love this logic, but that's fine. Private move count equal to 0. And then, anytime there is a valid move, you do this dot move count plus, and then everywhere I've done this dot board dot moves dot length, I can simply do this dot move count. Probably do it at the very end. If game is over, doesn't matter, but here I should be. There you go. All right, let's try that one more time. I think this should do it. The problem was this dot moves doesn't return the set of moves, it returns something else, which I don't know what it is. And I was banking on it, so I just am maintaining a move count variable myself. That goes up every time there is a valid move. Let's connect user 1, connect user 2. Let's init game user 1. Let's init game user 2. Let's send A2, A3 for white, and it reaches the other side. Let's send E2, E3 for black. I forgot to send it. I sent E2, E3 did got sent. Still did not get received on the other side because it's an invalid move. E2 to E3. That's probably possible. Chessboard. Let's see. Images. All right, we did a what the fuck? We did a A2 to A3. So we need to do a A7 to A6, I guess. All right, my bad. Let's try A7 to A6. Send. Go from this side. We did get received on the other side, so we're good to go. We have a game that's running. Of course, the front end isn't very pretty. We're sending out messages, but should be fairly easy to add. So that's what we'll do next. We have sort of tested the logic. It works for a single user. It'll probably work for more than one users as well. We don't have very clean logic to, if a user resigns, then let the backend know or the other side know that the user has resigned. But all of that is V2. V1 is creating the front end for it. So let's move on to that next. And also I'm a little bullish on L1s, non-EVM L1s. तो सोल के बाद एप्टोस तो ही आने वाले हैं, तो प्लस हम रस्ट सीखेंगे इस सोल में. So if you're learning Rust anyways, Move is just something more on top. Yeah. All right, let's get rid of the front-end folder here and initialize an empty React project. The way to do that is npm create Vite @latest. If in case you're using Vite, feel free to use a different framework. And let's initialize a basic front-end page very similar to chess.com. So the landing page would pretty much have a button that says join room, and we need another component that actually routes that the user gets routed to after they join the room. But maybe before that, I should add two dependencies here. Dependency number 1, Tailwind. Dependency number 2, React Router DOM. So let's kick things off by adding Tailwind as a dependency here. Let's go to tailwindcss.com. Framework guides Vite, and let's copy over the dependencies that you have to install. Initialize Tailwind, and then update tailwind.config.js. Add these 3 to index.css. Run npm run dev, and let's add a basic style to the join room button, bg-red-200, and let's see if it actually works. Seems like it's working. There is some style on the button. So now let's add React Router DOM next, because we'll have more than one page, so we need like some basic routing. There we go. A slash path that renders the landing page, and then a slash game path that renders the game page. Let's start by creating the landing page. So I'm going to create a new folder here called screens, which will have landing.tsx. And then maybe another screen here called game.tsx. Let me import the right things here, and then let's see if it works. Let me go to localhost colon 3000 after I start the application. So npm run dev, we close the sidebar. If I go to the landing page, I see nothing, even though I should see the landing component. If I go to the /game page, I see nothing. Probably see an error in the console. But not able. Not start with the base name. Oh, is there a base name somewhere? Let's get rid of it. Game page works, landing page works. For some reason, everything is centralized. So let's remove that from the CSS file. Yeah, and we're good to go. All right. Now we need to create 2 pages. The first page needs to look something like this: an image on the left, play chess online on the right, and a green button. Probably don't need this. Let's try to emulate this page as much as possible. I don't know if I want to save this image. So chess board images. My go-to site for images, chess board. See if we can find one here. It's decent-ish. Nope. The last one probably is going to be it. There we go. Looks pretty good. Save image as. Copy it over to the project. Rename it to chessboard.jpg, and then go to the landing component, and then let's try to create it very similar to what we see over here. So we need an image on the left, some text on the right, and a button below it. Let's create a top level div, give it some margin at the top, empty-2, and is there an app bar? There is no app bar. Let's add a div class name equal to grid that calls to gap 4 md colon grid dash calls dash 1 2 1. If you don't understand this, I will try to explain this once I finish coding. /chessboard.jpg, and then another div which has an h. Oh boy, does it know? Sort of knows. Welcome to, or whatever, play chess online on the number 1, well, I guess will be number 2 site. Let's move that. We need a button that looks pretty decent, that says play online. Yeah, it's pretty good. Let's see how it looks. Looks decentish. Scope of improvement, especially on the right side. Image is too big. Let's fix that. Image has a class name equal to m dash max dash w dash 48, or I guess 96, and it needs to be centrally aligned. So class name equal to flex justify center. There we go. What's the background here? It's blackish. So let's go back to app. Is that true for? Probably is. App.tsx, and then let's do a div class name equal to h dash screen, which means take the whole height, and background color is slate 800, and close the div tag. Color looks wrong. 400. Every color looks wrong. I guess complete dark mode is fine. Black color, tailwind, slate 900. Button is so big. P-8. PX-8. PY-16. Probably not that big. Text-2XL. 4. Color is greenish in color. Micro optimizations. I don't think we need to go that deep in the UI. Decentish. Yeah, there we go. That's what we have right now. Maybe restrict the width of the whole thing. Excel. This would be max. Screen MD. There you go. Decentish. Cool. This is the landing page that the user comes on. Scope for improvement, at least in the UI, but let's proceed for now. And focus on the core logic. We can always improve the UI. What happens when the user clicks on the play online button? They just get redirected to a page. Let's do that really quickly. Const router equal to users router. Oh god, how do you route in tail React router DOM. Use navigate. There we go. We navigate the user to /game. So if I'm on the landing page, which looks like this, if I click on play online, I go to the landing page. And now we need to update this landing page logic. This needs to have the chessboard on the left. Let's see. Yeah, pretty big chessboard on the left. And then a bunch of buttons on the right. Probably have like a play button. Don't need this right now. And then, yeah, don't need this either. Cool, let's build. I guess this is going to be the most difficult bit here. And especially the pieces. Yeah, it's going to be not very easy, but take it, let's do it. Class name equal to justify center flex and then div. Yeah, that looks right. And then div class name equal to grid. That looks rightish. Yeah, that looks right. And then this will be the chessboard. And another div will be, this utility area. Which I guess, is fairly straightforward. Let's just add a button here. Play. Initially, eventually it'll change actually. So yeah, we can define it later on. Let's create something called components here, where we add a chessboard.tsx export const chessboard equal to return div chessboard class name equal to text /white 200. Let's see how it looks. Looks pretty bad actually. All right. We have the chessboard on the left, play button on the right. Still have some work to do though. 2:1, so probably 6. Class name equal to grid dash calls dash span dash 4. Call span 1. Grid call 3 gap 4. Grid call 6 gap 4. MD. Let's get rid of that temporarily. Call span 2. There we go. Let me create a hook called use socket, which we're going to use pretty extensively. Cost use socket equal to move made came over. There we go. So you need this. No, we don't. Board comma side board equal to use state. How do you store the board on the front end? Yeah, that's the question, right? Right. How do you store the board on the front end? Let's just use game.js. Is that a wise decision, though? All right. That's what I want. Just a task guy. All right. That works. So what can we do? Let's add just.js to the front end. Equal to npmi just.js new js. There we go. And then anytime the game is initialized, that's fine. Probably just do something like this. If there is a move, then what do you do? Const move to message.payload. That looks almost right. Let's go to game manager. Type move payload. That's in the payload. That looks right. Put a move. That looks right. And then const ASCII board. Use state. I wouldn't say this. I would say it's an array. Oh, it is a string, is it? I guess it's fine. Just on board. Just equal to this thing, set board equal to just.board. Anytime there's a move, you move it. You call board.move. You call just.move, and then you are like set board just.board. Pretty good. And then chessboard needs to just take the board as the input, which will be a 2D array. What is the type of the board? Square type color. There you go. It's basically this. Alrighty. Now we need to render a few boxes. So let's create a, oh well, looks pretty good. Class name for this thing is square question mark square dot type. What's type? And then color. Yeah, that looks decentish. All right. Let's see how that looks. Let's see what an empty board looks like. Yeah, it looks pretty decent. Play buttons and this, and then okay. Let's see what an AI generated board looks like. Looks like a big fat error because the backend is down. So let's start the backend. Try that one more time. Still failed because the address is incorrect. It's 8080. Let's try that one more time. There we go. All right, that looks like a decentish board. A few inconsistencies we can fix. Number one, the colors are off. Even before that, square question mark BG green. I think that's what should happen. It should be an I plus J mod 2. Yeah. Plus J mod 2 equal to 0. That looks like a decentish board. Why is it not centrally aligned? Flex justify center. Looks so wrong. Looks decent. 16. Fairly decent. Let's get rid of the reds. Pretty good. Let's make the colors slightly better. What are chess.com colors? Green and white. So let's have green as one of them. And white, I guess. Looks pretty decent. Horizontally center aligned, and then div class name equal to h dash full justify center flex. There we go. Looks decent. Of course, we need to replace these with real characters, but great start. Move play towards the center of the board. Alrighty, too big to fail. What's up with this? Cool, that looks decent. Very, I wouldn't say very close to this other thing, but close enough, I guess. Yeah, it's fine. Is it resizable? Probably is. Yeah, it's pretty sizable. don't matter. We will fix this eventually. We have this. Let's remove the green color. Let's make it slightly more blackish. Slate 900. Cool, I guess. What else? Let's start to write the logic to actually move the pieces around. Or just, I guess if I click on this and then click on someplace else, the real move happens. So thankfully that's fairly straightforward. I can just pass along the socket here to the chessboard, and anytime the socket comes in, what do you have to do? Anytime you click on something, that will be a from. So const from comma set from equal to use state null, and then 2 comma set to. Given that you have this, anytime you click on something, on click equal to, if not from, then set from as square. What is square? Let's see. It looks perfect. Type of square looks perfect. Now type square. Oh. Okay. What is the type of this thing? Okay. Oh. I guess the other thing we should do is this a valid move? And only if this is a valid move should we do this. How can you check if this is a valid move? I guess put it in a try catch. I guess let's just assume it's a valid move, and then we can fix that later on. Let's see if movements are happening or not. Let's try to play a game. Set to socket.send type move and payload is a from and a to. That looks pretty decent. Let's also log that on screen so we know what's the from and to that went out. Alrighty, let's see if it works. I think we're pretty close, if not there. I've opened 2 socket connections, like 2 boards. I click play on the first one, I click play on the second one. I click over here, I click over here, and nothing happens. So it did not work. Let's open the console. Refresh the page, network. Look at the WebSocket connection, which is this connection right here. Look at the WebSocket connection, which is this connection right here. Look at the messages. Click on play. Nothing happens when you click on play. Let's go back to the play button. On click equal to socket.send JSON.stringify type init game. Oh, are there 2 socket connections? There are. There we go. My bad. Refresh. Close this. Fucking A. Refresh. Let's just restart the server. Refresh. Go to the last one. go to the last one, open messages, click on play, init game, click on play, init game. You are black and you are white. White is going to move first. If I click here and here, what happens? It says from G2 to null. So why is 2 null? I think it's fairly obvious why it's null. 2 is going to be right here. And let's try that one. Oh, locked the wrong thing. Cool. Let's try that one more time. Refresh, play. Let's see if the room has been made. It has been made. This is black. This is white. Because as you can see, the message that comes back says you're white. Let's click here. What is the message that went out? It says from G2 and there is no 2. Why is there no 2? Because square root doesn't exist. Why does square root doesn't exist? There is a from, there is no 2. Why? Oh. From G2 to E2. Oh. Hold on. What's the first one? Wrong. Everything else is. If not from, either way, after everything happens, I guess you don't need set 2. Just send this out and then set from back to null. All right, let's try that one more time. Refresh, play. Let's go to white and let's try this to this, which is from H2 to nothing. Let's try that one more time. This to this, from F2 to nothing. Why is the other thing nothing? Why would 2 be nothing? Square question mark dot square. Let's do a console.log square. Let's try that one more time. You're here. Refresh. Play. I'm black. From F2 was logged. From to null. Why? Oh, it is null. There's no square there. But that doesn't mean it's not. That's a p symbol is a square. Yeah, why is that? Why is the whole thing null? Let's see. Row.map square. What is row? Board.map. Row. What is board? Let's just log the board. Yeah, it's just null for those values, which is not great. So what can we do? Okay, where did it go? Square H1. So G1 H1 is the last row. Let's open a chessboard. That sounds right. G1 H1 is the last one. This is the last one. So we start from 8 A, I guess, A8 to H. Yeah, so given an index, how do you get the current square? Const square, I'm sure the library provides it to you. Chess.board. Chess.moves square. It's fine. Square equal to, it starts from, if 0, then it's A1, then it's B2, then it's C. So basically J mod 8 to char, like basically string of this thing 50 65 plus this thing. There's the first thing, and what's the second thing? There you go. That looks rightish. I mean, if square representation, let's log it. Console.log square representation. Close it. If I click here, nothing happens. Oh boy. Oh, a bunch of renders here. Why? Let's move that to firstly number to ASCII JS dot char code at 0. String dot from char code already. Let's try that. String is not a set of square. Cool. Let's see. From E9 to P9. That looks right. Eesh, that looks wrong. 1, 2. From F9. 9 sounds just wrong. A9, B9, C9, D9, E9. That pretty much sounds pretty. Second one is 9, no matter what. 8 minus math.floor, I don't know what that is. That AI has not done its job. It'll be J divided by 8 math.floor. That looks right. Refresh, close everything. This is A0 to B0. It should be A8 to B8. It pretty much means 8 minus that. 8 minus this thing. There we go. Let's try that one more time. 8 to B8, B8 to C8, C8 to D8, and this will be A8 to B8. Why is this A8 to B8? 8 minus sort of J divided by 8. This is also 8. Why is the second character always 8? String. Oh, that's my bad. No, that's right. Plus. Oh, J is also going to be that, dude. It'll be. Yeah. It'll be I plus J. Sorry, my bad. There we go. Alright, let's try that. D7 to D7. D7 to D7 looks wrong. Sounds wrong. Now it's always 7. Now it's 8, 7, 8, 8. Top left is A8. A8 to B8. It should be A8 to B7. I into 8. Oh, that's probably just I, dude. Yeah. Alrighty. Refresh. A8 to B8. B8 to C8. A7 to B7. B7 to D7. A0 to B0 or A1 to C1, I guess. B1 to C1, C1 to D1, D1 to E1, whatever, F1, I guess. Cool. Let's try that one more time. Let's go back here. Let's, oh, oopsie daisy. Restart the front end. Restart the back end. Refresh. Refresh. Oh, oopsie daisy, wrong one. Full confidence. Play, play. Make the first move, nothing happened. Make the second move, nothing happened. Oopsie daisy. Did early return as well. Oh, that probably makes sense. Here to here. Invalid move undefined. Okay. White. I'm going to move from here to here. And I sent a G2 to G4. Did I get a G2 to G4 here? I did not. Is it because it's uppercase? Probably. Because, you know, G2 to G4 sounds like a valid move. So probably need to do, what was it, 97? Play. Let's go with white. Here to here. B2 to B3. Did the other side receive it though? That's the question. And it did not. Why? Because it says this is an error, invalid move, undefined. Why is B2 to B3 an invalid move? B2 to B3 sounds fairly valid. Is that the one that we sent from B2 to B3? Yes, that's what we sent. Was it an empty board? It was an empty board. Let's search for chess.move. Let's just log the payload here, shall we? Hold on. We also need to make the move locally, or should we? Probably should. Board.move. Let's see. Let's go back to game.tsx. We have a board variable here, and we had a chess variable here. Only the board would update, I guess. Yeah, we would move and then update. So copy both of these, send it down as a prop. Not the best idea in the world, but that's fine. Alrighty, set board. Fix this later. Whenever the move happens, oh, you have to do more than that. Do a chess on move and then chess on board, so we need to pass chess as a prop as well. Fix that later. There we go. Refresh. Forget everything. Let's do refresh, play followed by play, and let's see if a local move happens at the very least. If I move this, an error comes, it's okay. It'll probably be the same error. Cannot read property of undefined. Move because we're not sending. Chess as a variable. Let's try that one more time. Refresh, play, and then, you know, white moves. I did move at the very least. It's good. So the move happened. The problem is did not reach the other side. Why? Network tab, local host, never reached the side. Because the server probably said it's an invalid move. Why does the server think this is an invalid move? When locally it's not an invalid move. That sounds super wrong. Let's go to the server. Game.ts. Let's not log this. Where is it? Looks right. What's the move? Let's just log the move. Console.log move. Cool. Let's try that one more time. This is the backend. So tsc-p node/index.js. Refresh. Play. Let's go here. Send the move. What does it say? The move was, oh, undefined. What am I sending? I am sending board. Type move and payload is something, but what are we expecting in game manager.ts? We're expecting, so I need trpc, man. Message.move. So let's just If I'm being honest, let's do this. Keep things a little more consistent. Alrighty. Cool, let's try that one more time. tsc-b, node/next.js, refresh, play, and then let's move white. Let's move black. Oh, oopsie daisy. At least white moved both the places. That's a good start. Black did not move though. What's up? From D7 to D5, early return 1. Invalid move. Try that one more time. This is going to be white. This is going to be black. White plays a move, it reaches the other side. Black plays a move, it's considered to be an invalid move. Why? Invalid move from h7 to h5. Why cannot black move from h7 to h5? Why is that an invalid move? Why is h7 to h5 an invalid move on this board? Unless I'm missing something obvious. And the server crashes with the same thing. No. Sounds like we're good to go. Moved successfully once and two. Sounds like we're good to go. Which basically tells me the board isn't being updated correctly. What are we doing when we receive an event? Let's see. When we receive an event in game.tsec, forget on message, we pass the message. If the type is move, we do a message dot. Oh, there's probably something here. No, that's right. Most probably that's right. Are we doing a set chest somewhere else? Break is fine. No. Are we updating you somehow? And I would guess no. This worked for sure. Set board. What we can do is go here. Let's print the board when that happens. So let's do a console.log of or just let's just do that. Refresh. Inspect sources. What is this game manager? The fuck? Oh, sorry. Game.tsx or probably chessboard.tsx before you make the move, which is, yeah, we already, maybe not. All right, let's kick things off by play. White will make a move. I move from here to here. Set from null. I mean, that's fine. It'll just work. Now black was supposed to make a move. Let's see if we make a local black move here. What happens? Before we do this, let's look at the board. Let's do a chess.board. And let's explore it. Well, it looks right. Let's move from here to here. That looks right. Let's go to the network tab. Well, I guess it does work here. Fine. Yeah, it just fails the other place, right? If I do the same thing here, it'll be like, no, sorry. Why is that? Let's log. Even though the board has been updated. Before you move, let's try that one more time. Oh, oopsie daisy. Over here is fine. Let's do a chess.board. And let's look at the, there you go. Board is never updated. It still has the initial configuration. Why is that? Is it stuck in some effect? Probably not this. Probably stuck in some effect. Just board. Oh, sideboard. No, that's fine. Chess, what are we doing here? Yep. That looks fine. What is wrong with game? We go to this thing. Break, move, break. this chess.move has happened on the wrong chess variable, I guess, because init game updates it and this is bound to the wrong one. Yup. Fuck. This would have been very hard for a junior engineer to debug. Yes, I hate callbacks. What can we do? What we can do is, let's not worry about resetting the chessboard, because yeah, that should do it. Yeah, I should do it. All right. Refresh. Play, and then let's start here. I made a move. It happened on my side, also happened on the other side. Let's make a move. It happened on my side, also happened on the other side. You have a multiplayer chess game. There you go. Move up. Kill the other side. Move up. Move down. Sorry, this is the wrong one. Now I'm screwed. Move up. Move here, maybe. Kill the pawn. Oh, maybe it's mine only. I don't know, white. And then black can move like this, and then white can probably equal out na. Oh, wrong one. Equal out. There you go. Move like this. And then I will also take out my knight, and then, yeah, keep on going from there. All right. Given that we have a multiplayer chess game done, almost, let's add some color. Let's add some, update the characters somehow, even though it's not super necessary at this point. Yeah, let's just prettify it and go from there. Let's get rid of the play function button when you're actually playing, so on and so forth. All right, cool. Let's do a const started, set started equal to use state false, and then anytime it starts, you'll set started to true, and then anytime started is true. You don't need the play button. So if not started is when you let the user see the button. What else? We need all these assets. So chess assets, images. Yeah, I just need all of them individually. Or I'm sure there's an easy way to do this, but we don't like easy. How can I download this? Oh God. Hello, can I go? Yes, but it's I guess it's fine. We can give attribution. Let's log in. Let's an easy way to download it. Oh. Alright, I probably will speed ramp me downloading these files. Alright, spend some time bringing in the images locally. So I have, n.png, which is the knight in black color, and then capital N copy.png, which is the knight in white color, so on and so forth. All of these characters come from, chess.js and how it represents the board. If I open the documentation of chess.js, you will notice the board is represented like this. P stands for pawn, capital P stands for pawn for white, so on and so forth. So given that the board is already represented like this, I've created a mapping from these characters over to these images, and I'm using them over here. Earlier, I was rendering simply square dot type here, which is the character, be it P, R, N, so on and so forth. And now I'm rendering an image tag, the source of which is slash square dot. If it's a black piece, then it's simply square dot type, else it's square dot type dot to uppercase space copy dot png. Basically pick either k dot png or capital K space copy dot png based on which piece you're trying to render. Now if I start the front end and back end, so let me do that really quickly. Node I can pretty much, join as two players. So open this on the left, open this on the right. The first player joins, second player joins, first player clicks on play, second player clicks on play, and the game begins. The first player is white, so they can move. The second player is black, so they can move. And as you can see, the game is synced and the characters look decentish. I think the design can be updated, but you get the idea. We have a real-time synced game, and we can have multiple rooms running. If there is one room currently in which people are playing, we can have another room right next to it, where two other people can join and they can have their own game, which looks different from the first game. You get the idea. It's fairly straightforward stuff. The only thing that's missing at this point is adding, there is draw logic on the backend, but actually showing a confetti if someone wins, so on and so forth. But that's low-hanging fruit we can get to eventually. We've built a slightly basic version of a multiplayer game where you can have multiple rooms and people are subscribed to the right set of events. It's not distributed yet, it's not scalable yet, it's not fault tolerant yet, which is what we'll discuss in the next video or next sections of the video. How do you make this a little more scalable if you're expecting a traffic similar to, chess.com, which as you can see, has like almost 150K online at a certain point. How can you handle traffic like this? All right, day 2, had a good night's sleep, thought of some architectures, and in this section we'll be going through slightly better system design of how you can add some recovery mechanism, make your system more resilient to failures, and then how would you scale an application like these if you have 10,000 games running, maybe 100,000 people watching. How do you need to switch the architecture a bit so that it scales to as many users? A single server isn't enough to handle such a big load. Let's understand these one by one, and eventually we will be implementing these. So if you want, all this code is present on code100x/chess. I'll probably create issues by the time this video ends. Feel free to pick them up. Most probably I'll be the one working on these two, but they're like smaller low hanging fruit. For example, chessmate mechanism showing some sort of a confetti when people win/lose, database authentication, making the UI prettier, all that jazz. There'll be bounty associated with all of them. If you're in the cohort, feel free to contribute. If not, just feel free to shadow all the issues. With that, let's understand a slightly better system design that includes recovery mechanism. Before that, what exactly is recovery mechanism? The problem with our current approach is that if the server goes down, if our WebSocket server, let's make this a box. If our WebSocket server goes down, and let's say there were two people connected to it, browser 1 and browser 2, who were currently in a game, which means they had persistent connections and they also had an in-memory object on the server which stored the current state of the game. If this server goes down, this in-memory data is lost. This server is what's called stateful. This WebSocket server is stateful, which means if the server ever goes down, the state gets lost. We never persist the data in a database or someplace else. So the first thing that might come to your head is, Kirat, let's just persist everything in the data. There is no point having an in-memory object. Whenever a user comes and we start a game, every move we should just, let's say there was a E3, E4 move played or whatever move, we should just persist this to a database, Harkirat. And the database should store the complete list of all the events. That way, if the server does go down, we can always bring it back up and the final source of truth for the data is here. We can make our server stateless. This is true. There are some problems in this approach that we'll discuss very soon, but that's the high level idea. You want to keep your servers as stateless as possible, because if you introduce state into your server, if the server ever goes down, the state gets lost with it. So at the very least, we need to introduce a database. And anytime two people join, anytime a game is created between two people, we should have an entry in the database. Let's assume this is a NoSQL database. I would ideally use an SQL database, but assuming it is a NoSQL database, the game will have an ID. It will have the identities of both the users. So player ID 1, player ID 2, and it will have the moves that have been played in this game. Let's say the first move is E4, E2, E3. The second move is G2, G5. I don't think these are valid moves, but you get the idea. We store all of this in a database. The server doesn't hold a state. The server doesn't hold a state. You mean there is no game object here? Yes, that is what you would assume. But the problem is, if you don't have any state on the server, what happens when the user sends you a move? E5, E7, let's say. If the user sends you a move, you will first have to bring all of these moves in memory. Check, is this a valid move? Can I put it here? And then add the move here, which means, every move becomes an extremely expensive operation. Whenever a user tells you I want to move from E4 to E5 or E7, you need to hit the database, check the current set of moves, probably bring them in memory, validate, is this a valid move? Can I add E5, E7? And then push it over here. This becomes problematic, which is why in this case, unfortunately, you need to maintain a state on the server. You can get away without maintaining a state, but then every move operation becomes extremely expensive. And hence, the ideal approach here is that you do have an in-memory object. This in-memory object does have a list of moves, has the board object in memory, or the chess.js object in memory. And you can very quickly validate, is this a valid move or not? And if it is, you persist this in the database. Harkirat, then what is the point? You are maintaining the state here. You are maintaining the state here as well. What is the benefit of maintaining the state on the server? You never used this state. You just put the data here. You never used it. You're just pushing data here. That is true. The benefit of persisting the state is, if this server ever goes down, if the server ever crashes, whenever the server comes back up, let's say AWS had an outage, the server went down for 5 minutes. When the server came back up, you can always recreate the game from the database. You can bring the game from the database to in memory and recreate the game. You add recovery mechanism to your game by adding some statefulness to it by creating a database. So what did we discuss in this specific section of the code? We discussed, if you want to create a WebSocket server, if you have a real-time game, most probably, doesn't matter what the game is, could be Counter-Strike, could be Ludo, could be chess. Most probably you will have to maintain an in-memory store or an in-memory game object. So every browser of yours that's currently playing with each other will be connected to the same server, and they will have an in-memory game object which will, store all of their moves, player ID, so on and so forth. But you probably also want to persist this in a database. Anytime there is a move that comes, validate, is this a valid move? And if it is, let the other party know. Also store it in the database so that you can always recover the game from the database. This becomes useful in a lot of cases. You can replay the game. You have a history of the game stored somewhere else. You can, share the game in the future with someone else. So other than recovery, this is also useful for, just keeping track of a game that had happened in the past. But more than that, if you don't want any of these features, if you don't want a place where, I'm sure chess.com has it that you can replay a game. But even if you don't want this feature, purely for recovery, storing data in a database is a great idea. Okay, Harkirat. So what you're saying is, if this was my code base, if you were thinking of making this change, even though I'll be the one that will make this specific change, so don't PR this or feel free to. So what you're saying, Harkirat, is in the chess dot, let's see, in the make move function, I would, after doing a this.board.move, if it succeeds, I probably want to do a db.moves.push, whatever the current move was. I want to persist this in the database as well. Sort of. That's pretty much what we want. Yes. Are there issues in this? Is this code right? There are some problems in it. For example, what if the database is down? What do you do in that case? But these are, inconsistent, like edge cases that you can think of. If the server is down and the user sends you a E3, E4 message, then you unfortunately cannot store it in the database. So you have to let the browser know that, our backend is down. But most of the times the database will be up, so shouldn't be a problem. Another problem in this approach, can you guess? What is not a problem, but what is one bad thing that will happen if we add a database in the logic? It's latency. Now, whenever a user is sending you a move, you're not doing just in-memory calculations and letting the other party know. You are doing in-memory calculations, making sure is this a valid move, and then you are storing the data in a database. That can take a long time. This database might be someplace else. It takes time to persist it to the file system. So this put call might take a lot of time, and hence moves getting transmitted from user 1 to user 2 become slightly slower. This becomes super important in a high stakes game where, it's let's say a 10-second blitz match. Latency matters a lot, and waiting for a few milliseconds to store data in a database is not the best thing in the world. So what can you do? Can you think of a better approach of how can you, number one, do the chess validation, number two, send the data to the other party, but also persist it slightly faster. How can I persist my data slightly faster rather than putting it in a database? The answer is you can store it in some sort of a like you can store it in the file system here, you can store it in Redis. You don't have to necessarily hit the database. The database can eventually pick it up from Redis. So ideally what you want to do is whenever a move comes, you do the validation and then you quickly throw the move somewhere from where it can eventually be put in the database. So you quickly throw this specific move, let's say, in a file, even though the file is not the best place to put it, because if the server goes down, the file goes down with it. You can store it in a Redis queue. You can store it in a elastic file system, or not elastic, a networked file system, so that whenever a move happens, let's say E3 or 4, you quickly throw it somewhere and you move on to the other side. Eventually it gets picked up from here and put into the database. So you do have a way to recover. You do have a way to recover this specific move, but at the same time, you don't wait for it to be thrown into the database. You throw it somewhere quickly and then let the other party know, okay, yeah, good to go. Eventually this will get put into the database. This is a slightly better approach for whenever you want to maintain in-memory objects, but also store them in a database, but don't want to wait for the store event. The same thing happens, in an application like an exchange, where if you're on this page and you see this order book over here, this order book is also in memory, which basically means it's a variable in a Rust process. So whenever this order book changes, you want to update that in memory variable, but you also want to throw this information somewhere. Eventually someplace else should know, or eventually this should reach the database, some queue, some place from which we can recover this order book, because maintaining an in-memory object is very dangerous, because if the server goes down, the in-memory object goes down with it. So you either persist this in-memory object to a database, but since this takes a long time, you can actually throw it to a queue and eventually, or just write it to the file system and eventually pick it up from the file system, throw it in the database, so that recovery can happen in case the server is ever down. Hopefully that is clear. If not, that is fine. I think even the normal approach of not throwing things in a queue, but just storing it in a database is fine for now. So whenever a move comes, let's say E3, you validate, is this a valid move? And if it is, you throw it in the database. And if this put succeeds is when you let the other party know, okay, hey, a put has succeeded. Now it's your turn. And then this party will make a move. Again, it will get persisted to the database, go back to browser 1, so on and so forth. If you want to micro optimize, you can save some time by not storing it directly into the database, but throwing it someplace else and eventually persisting it to the database. That is how I would build recovery mechanism in a chess-like game, which basically means if this server ever goes down, if you want to bring it back up, you should be able to recreate the state, because it's very common for servers to go down from time to time. And storing things in memory is not the best idea, because if the server goes down, the data goes down with it. The browsers are pretty much lost as to where is my game. I don't know the game state at all. Right. Here is a simple issue that I've created. If you want to shadow it, feel free to. If you want to PR, feel free to. I might not be able to merge it, but here's how it goes. It says, let's create a simple Postgres table plus Prisma ORM, which stores all the game information. Whenever a new game is started, create an entry in the games table. As the user makes moves, store it in the moves database, which has a foreign key to the games table. So all the moves will be created in a separate table, which has a foreign key to the games table. Add IDs to every game that is created, and a new event that lets the user rejoin a game with a given ID if their Wi-Fi went down. So if we're implementing both way recovery, right? If the browser goes down and comes back up, the user should be able to rejoin the game, which means, there needs to be some sort of an identifier of a game ID that the browser sends or the user sends, hey, I am player one in this specific in this specific game. And the other sort of recovery we need to do is, if the user wants to join a game when there is no in-memory game, which means most probably the server restarted, then recover the game from the database and put it back in memory. These are the 4 things that need to be built. Given this information and given the base code base in probably the main branch by the time this video is released, but currently in the hq./base branch, feel free to PR it, feel free to try it out, feel free to shadow it. Let's move on to understanding how would you scale a system like this. All right, let's understand how do you scale this real-time game now. Until now, we're making a very big assumption that there is a single WebSocket server to which a bunch of people are connecting. And this approach sort of works if I have, 3 users, 10 users that are playing 5 games against each other. But if you look at it, chess.com has 142k people online right now. That means the scale that you need to work at cannot be handled by a single WebSocket server. You need multiple servers and somehow need to scale the application if the number of users that you have is closer to this number. How can you scale? Can you do this? Kirat, if there are 142,000 people on my website, I can just have maybe 142 servers running, and each server will have 1,000 people connected to each other. Decent approach. If you know a single server can only handle 1,000 people, and then there are 142,000 people currently live on your website, or 140,000 people, you can start 140 servers, and you can make sure that our first 1,000 people connect to server number 1, and then the next 1,000 people connect to server number 2, so on and so forth. There is just one extra thing you need to keep in mind. That thing is, 2 people who are in the same room, 2 people that are playing against each other, need to be connected to each other. If this person and this person are currently playing against each other, they need to be connected to the same WebSocket server. There needs to be some level of stickiness. You need to restrict if person 1 and person 2 are currently playing against each other, they're connected to the same WebSocket server. If person 3 and person 4 are currently playing against each other, then they're connected to the same WebSocket server, so on and so forth. You want to avoid your best, not avoid your best. You definitely have to have this restriction, because if player 1 and player 2 are playing against each other and player 1 is connected to WebSocket server 1, but player 2 is connected to WebSocket server 2, if I emit an event to the server, I want to make a move like E4, it cannot be transmitted back to the other person without these servers communicating with each other. And we don't want WebSocket servers to communicate with each other just yet. We want to shard our application, which means, what does sharding mean? It means that everyone who's currently interested in a certain part of the code base, or everyone who's currently interested in certain events, please connect to the same server. If you are part of room 1, please choose a server, connect to it. If you are part of game 2, let's say, and you're playing against each other, then please connect to a random server. Does not matter which one. You can choose the one with the minimum load, but you have to make sure that the 2 people that are currently in a room connect to the same WebSocket server. They're not connected to different WebSocket servers. So that's the first approach of scaling, which is you have a fleet of WebSocket servers. You can increase the number of servers or decrease the number of servers based on the current people on the website. But in the end, you cannot randomly choose servers. Whenever a user comes to your website and starts a game, you have to pick a random server for them. But you have to make sure the other person that connects to the same server is also other person that connects to the same room is also connected to the same server. You need to add stickiness to your code base. This approach is decentish. In fact, this is an approach I've seen many times. When you know that the number of people in a room are less than a certain number. For example, if you look at a website like GatherTown, at least while I was there was some level of sharding that happened very similarly, which is, if there are people in a certain room, this is like a multiplayer game. There are people in a certain room. They're all connected to the same WebSocket server that's relaying information. You don't connect them to different WebSocket servers because it is the responsibility of this WebSocket server to relay events. As soon as you connect this other person to another WebSocket server, because you're like, oh, I will, scale very fancily and allow anyone to connect to any server. You cannot emit events from this WebSocket server to this WebSocket server back to this user. That becomes slightly complicated unless you make the servers talk to each other, which we will in the next section. So what is the learning for now? The learning is if you want to scale initially to more than 100 users or more than 10,000 users, more than 50,000 users, you can have a fleet of WebSocket servers and just make sure, if a new game is started, pick the WebSocket server that has the least load and connect both of the users to that specific room or that specific WebSocket server. And then as a new game is started, then pick a random WebSocket server that has the least load and connect both the users to them, so on and so forth. As spectators join, make sure if a spectator is joining on game 1, which let's say, is the game that this player and this player are playing. If there is a new spectator that joins, what is a spectator? A person who wants to just look at the game and not play. You also have to make sure the spectator connects to the same server. So what have we done? We have done scaling via sharding, which is usually not the best approach, but it works fairly well for small multiplayer games. And by small multiplayer games, I mean this application cannot support 1 million users. This application can still support 1 million users. It cannot support 1 million users in the same room. It can support only, let's say, 3,000 to 4,000 people in the same room. But overall, the number of people can be a lot. It can have 10 million users. You just need to have, 10,000 servers if that's the case. So that's the only restriction in this approach. A single room cannot have more than, let's say, 5,000 people because a single server cannot handle relaying events to more than X number of people. In case of chess, this is a fair assumption. I don't think, unless, of course, there is a very popular game that's currently going on and everyone's spectating on it. Most rooms will not have more than 5,000 spectators. So this approach will just work. But what happens if there are more than 5,000 students? What if there are a lot of people currently spectating on a game? Harkirat, then all those people will connect to the same server? Yes. But a server can only handle a certain number of connections, cannot handle 1 million users? Yes. Then how do you scale? How do you make sure you have multiple servers, server 1, server 2, and people in the same room can connect to different servers? This person are all currently interested in game room 1, but they're connected to different WebSocket servers. How can you relay information between WebSocket servers? That's what we'll discuss next. This is a standard way to scale WebSocket servers, so there's nothing new here. It's a fairly common architecture. All right, let's understand if a single room has 1 million users or 100K users, how can you scale your application? How can you support 100K people currently interested in the same chess room? Number one, if there are 100K users, you definitely need a lot of servers. A single WebSocket server cannot handle these many connections. So at the very least, you need a bunch of WebSocket servers. Let me create a bunch of boxes here. Let's say you have 10 WebSocket servers or whatever this number is. And each of your 10,000 users are connected to one of these servers. So the first 10K users over here are connected to WebSocket server 1. The next 10K users over here are connected to WebSocket server 2. The next 10K users over here are connected to WebSocket server 3, so on and so forth. You have people in the same room connected to different WebSocket servers. And let's say, the player 1 that's playing the game is over here, which means it's connected to WebSocket server 1. And player 2 that's playing the game is connected to this server, which is WebSocket server 2. Now this becomes fairly challenging. Why does this become challenging, Harkirat? Because whenever player 1 makes a move, that move needs to be validated here, which means I need to have an in-memory object, an in-memory representation of the game here for it to be quick and quickly understand, is this a valid move or not? Then I need to transmit this event to WebSocket server 2 also, WebSocket server 3 also, 4, 5, every other WebSocket server, because every server has people interested in knowing this E4 event that might have happened. So whenever your player one, let's say, sends a message to their WebSocket server, it needs to be relayed to every other WebSocket server, which means we need some sort of a PubSub system here. PubSub queue doesn't matter. Probably PubSub is the easiest and the cleanest solution here. You need to emit this event to a publisher subscriber, and every other WebSocket server that currently has at least one user that's interested in that room will be subscribed to this event. And so this E4 event, when it reaches WebSocket server 2, which relays it to this user. It also reaches WebSocket server 3, which relays it to this user, so on and so forth. We need another service on top of all of our WebSocket servers, a PubSub service, where whenever a user makes a move, this gets published to the PubSub, and this PubSub relays this information to every other WebSocket server that's currently interested in this event. Why would this WebSocket server be interested in this event? If there is at least one user that currently is connected to this WebSocket server and is part of the same room amongst these 100k users, then this WebSocket server will be interested in this event. This WebSocket server will let the PubSub know, okay, I have at least one user in this room. If you get any message for this room, please forward it to me. And that is how you would scale this application without sharding. What are we doing? We are not sharding anymore. We are saying, okay, our player one will emit an event. It will go to a PubSub, and from the PubSub, it will get emitted to a bunch of WebSocket servers through which it reaches the end users. The end users can now connect to different WebSocket servers. Why is this good? Because a single room can now support more than, well, technically infinite people, not really infinite people, there is a limit to how many messages a PubSub can have, but this will scale really well. If you have 1 million users, or let's say 100k users, then you only need, let's say 10 servers. Let's assume every server can handle 10k users, probably slightly overestimation, maybe like 8k, 7k users is something a server can handle. Given 100k users, you can have 10 servers. If you had 1 million users, then you probably need 100 servers, which means a single event needs to go from a PubSub to at max 100 other servers for 1 million users. So since there's another layer of, it's like a tree like layer over here, right? This is the PubSub. It is talking to a bunch of WebSocket servers, which are talking to a bunch of end clients. So the reason the PubSub does not become a bottleneck is because if you have 1 million people here, you only have 100 servers here, which means the PubSub only needs to hold 100 connections. And if there is an event, the PubSub only needs to forward it to 100 people. The 100 servers then need to forward it to 1 million users, which is why there's a very low probability of this becoming a bottleneck. If you think this will become a bottleneck, then, there are other ways of scaling this, adding another layer of trees over here, which means, you will have 3 PubSubs. These are things that people just think of and never implement. These are just conversations I've had while I was at a multiplayer company. Okay, you can probably add another layer of PubSubs here, and then, keep making the layers smaller and smaller. But you don't need to scale that much usually for any game, especially for a, website. If, the biggest chess website is currently probably at peak having 200k online people, you'll be fine with like a single PubSub. This PubSub should be able to handle all the events. And yeah, that's pretty much it. That's how you scale to 1 million users interested in the same room. Again, you only need this approach if you have a single room where 100,000 people are present. If the people are distributed across rooms, then the previous approach of sharding is actually pretty clean, and one that I would pick because it's slightly simpler, cleaner. But the reason this approach is slightly better is because, you can regionally connect to servers near to you. So, if I'm in India, I can connect to my India WebSocket server. If I'm in the US, I can connect to a US WebSocket server. But the problem is, you're running the game logic multiple places. There is an in-memory game object here. There's an in-memory game object here. So there are pros and cons. I would not build this for a really long time, unless I know there is an event where, the biggest chess player is playing and there will be a lot of people in a single room, at which point, it will make sense to build something like this. That's a brief of how you scale beyond 10,000 users in a single room. But yeah, I'm not creating an issue for this because 2 reasons. Number one, a lot of this is highly DevOpsy stuff, so there's not a lot of code to write. Well, there's some code to write, but not too much. And secondly, not something I'm super interested in this is what's called over engineering, right? Building something so far ahead when you don't even have 2 users. So let's focus on getting more people to play this, and when they do, we can eventually figure it out. All right. Given that, I think the one thing that's left is deploying the application. Should be fairly straightforward. The only problem is the server is the application is highly fragile now. What do I mean when I say fragile? I mean, we're not doing validations the way we should. So, a good example here might be if you go to the backend source. Well, we're doing it on the backend, not on the front end, but let's see if I can find, some obvious things that we should do but aren't doing. I should also remove all the logs. Standard things like if the game is actually over, letting the user know. If there's ever a crash, not try catching it, and the server will just die. Things like these. There are a lot of low hanging fruit here, so you should fix that. Run it locally, and at the very least, the UI is pretty janky. So add, drag and drop to. I'll just create a few issues. If you want to pick them up, feel free to. If you're part of the cohort, you can also win a bounty for it. Anywhere between $10 to $200 based on the effort. Add, drag and drop to the game board. I think it's fairly self-explanatory what needs to be done here. Make UI similar to a famous chess website. I think it's the UI is fairly janky right now. Add auth. Login using Google/FB/email pass. I think there are already PRs that do a bunch of these things, like bootstrapping the application. So yeah, by the time you see it, most probably the shape of the main branch has changed a bit. It's probably a monorepo with some of the code that we've written today, but that's a brief of how you build a chess application. If there is one issue you want to target, it's probably this one right here. If given the base code base, try to do this. This is a decentish issue to check where you're at. Do you understand other people's code? Can you write more code? You might have done basic Next.js applications or HTTP servers. This is something extra. This is WebSocket. There's no concept of HTTP here. How do you add an ORM here? How do you create a database? Things like these. So think about it a little bit. And if there's one thing, if you've seen the video right now and you understand everything, if you've written the code yourself, if there's one thing you can practice yourself, it's this. I'll end that here. I think, yeah, it's a decentish architecture. With that, let's end it. I'll see you guys in the next one. Bye-bye. Full screen. I'll see you guys in the next one. Bye-bye.